folks. Welcome to the News and Community Spotlight. The final two tech talks from GDC, new animation features, and Causing Chaos, the future of physics and destruction, have been released. If you weren't at the show, you can watch all our technical sessions from the Yerba Buena Center for the Arts and our Booth Learning Theater online. Dive in for the latest on all Unreal features. Recently released Dangerous Driving, which some call the spiritual successor to Burnout, was astonishingly developed by 7 people within 7 months. With 9 racing modes, 27 vehicles, and 7 different locales, it's also easily the company's most ambitious effort yet and represents the culmination of their work. We had a chance to interview Three Fields Entertainment Technical Director Phil McGuire as he discusses how the studio is able to execute on their vision with limited time and resources. He also shares how they balanced creating an arcade racing game that felt familiar yet fresh, reveals how they leveraged UE4's physics to create more realistic crashes, and elaborates on how they delivered a game that runs blazingly fast and smooth. FMX 2019 is just around the corner, and we're really excited to have a packed schedule of demonstrations, sessions, panels, and networking opportunities lined up. If you'll be at the show, stop by our booth to see a demonstration of Chaos, our new physics system, and the gorgeous Troll cinematic created by Goodbye Kansas. There will also be a number of sessions on the use of Unreal with digital human creation, virtual production, the Meg, Mad Max, and more. A team of 8 students from Soup Info Game Rubica worked on Guard as their graduation project for their final year. On Guard is a swashbuckling action game prototype made with UE4. In a fantasized vision of the 17th century, the player embodies Adalia de Volador, an impetuous swordswoman who must fight with panache to defend her family's honor. Read their full guest profile on how the small team addressed design, art direction, general development, and more topics. We'd like to thank our top weekly Karma earners. These lovely individuals are jumping into AnswerHub to answer questions for their fellow devs. Nebula Games Inc., Every Nun, Shadow River, T. Sumisaki, Christoph Morva, Thompson N13, Cold Steel 48, Pan Wilson, and ICOB. Thank you all so very much. In our first spotlight, crafty squirrels organize a tournament to challenge other animals in a physics-based competition. Make daring plays alongside your teammates, grab food power-ups, and tackle your opponents to steal their nuts in this wild, multiplayer-focused party game out now. Based on the work by Neil Gaiman and Dave McKing, Wolves in the Walls transports you into the magic of virtual reality cinema, where only you can help Lucy discover what's truly hiding inside the walls of her house. This immersive fable asks, what would it be like to interact, have a relationship, and go on a quest with a character inside a virtual reality movie? Retro Rockets is a retro future multiplayer game where you hunt retronauts and deorbit space stations as Destructo, or play as the retronauts and work together and defend against Destructo by enabling the security systems that will make the killer robot rest in pieces. All right, thank you for joining us for our News and Community Spotlight.
Hey everyone, welcome to the Unreal Engine livestream. Today with me, I have fellow community manager Amanda Bott. I'm your host, Victor Broden, and with us on the line, we should have Dan Reynolds. There he is. Hey
Dan.
Daniel.
Hello.
Technical sound designer.
How's everyone doing?
Hope they're doing well. He will be showing us a little bit how to use TimeSynth in Blueprints today. But before we get started with that, I'd like to let everyone know that we are going to be giving out some keys in chat to Save Your Nuts that you saw in one of our Spotlight trailers. The team have been nice enough to give us a couple of keys, so stay tuned. And don't worry, they won't be taken by bots because we have screen capped them, and we will be posting links to the actual
Just got to
image.
be faster than your friends.
Yes, yes. Being quick there. And please just grab one. Grab one for yourself and let everyone have one. All right. With that all done, Dan, would you like to get us started?
Yeah, sure. So for those of you who don't know me, my name is Dan Reynolds. Hello. I'm the technical sound designer on the audio engine development team here at Epic Games. My role is basically to work with the audio programming team to develop new features, to prototype new ideas or help consult on feature dev, and then assist them in testing and demonstrating and doing things like this live stream.
Yeah.
I've been in games for, I don't know, something like 13, 14 years. So I've done a lot of different stuff. And for the last few years, I've been at Epic doing stuff like this. So, yeah. So that's me. One of the things that we released in the last update as an early access feature is this new time synth component. And so that's what I'm hoping to talk to you all about today. So yeah, just as a quick sort of backstory, the time synth component was sort of developed in this sort of prototype fever in, I think, last October. So that's kind of where it got its seed. But yeah, so I'll kind of, let me get my slide up here. So let me talk really briefly about what the time synth is, what the time synth is not. And so the time synth component is a early access synth component plugin, and we see it as the sort of core chunk, the core thing you need to develop timing critical audio applications, like interactive music systems, which is what I'm going to be talking about today. The way that it was developed, it's kind of like a miniature audio engine, and you'll see more how that is the case as I go into it. It has its own quantization clock, which is sample accurate, which is something that is necessary for timing critical audio applications, and it has event delegates for communicating the timing information to the gameplay. Its sort of core, the way it sort of works fundamentally is that it allows you to cue audio ahead of time. So you can think of it in some ways as an audio scheduler. It supports volume grouping, and it has some built-in effects. So it allows you to do some internal mixing within the actual synth playback. It is, to emphasize, the core element necessary for developing something like an interactive music system. It is not itself necessarily an interactive music system. It can be used in many different ways. So kind of going back to last year, the last time I was on here talking about making interactive music in Blueprints, a lot of what last year was about was how do we make an interactive music system in Blueprints now, with the sort of challenge that we had at that time. And so there was a lot of work around, and if you review that stream, then you'll see kind of a lot of like the tricks that I pulled. But for this case, for anyone new, or if you've forgotten, I'm just going to quickly review what sort of challenges we're talking about when we're building an interactive music system in Blueprints in the Unreal Engine. So one of the sort of essential concepts for creating dynamic and interactive music is something we call music stitching. And music stitching, or audio stitching, or whatever, sometimes called concatenation, is this idea where you can say, break up a piece of music into smaller sections, and then have one immediately lead into another. And so the illusion is that it's a continuous piece of music that is actually made up of several smaller pieces. And the reason why this is really important for interactive music is because during gameplay, you want the music to be able to respond to changes in game state or information that maybe changes during the music playback. And so with stitching, you can maybe say have a music clip, and then maybe based on some game logic, it could pick one clip or the other clip. And so here as an example, I have a music clip A that could potentially lead into, say, a B clip or a C clip based on some sort of game interaction, right? So that's what we're like looking. That's what we're after. What is the problem? Well, in the Unreal Engine, one of the things that you need to appreciate is that all of the gameplay logic exists on what we call the game thread. And the game thread is basically updates every time our video render updates. So a new frame is updated, right? So if you have a game that is running at 60 frames per second, that means your game thread is updating 60 times a second, is updating its information. All the state is being reevaluated, all the ticks are being executed, etc. Now, unfortunately, our video render frame rate is not necessarily going to be timed with our music. And so what often happens if you've attempted to build a music system inside of a game engine using where the game thread is locked to something like a video render frame rate, or the game thread has like some sort of static update tick, then you often find that that music will end, but then by the time we know that it has ended, already some small increment of time has passed before we can act upon that information. So in the illustration I have here, we can sort of pretend these little triangles are our game thread update ticks, and every update it evaluates, has music clip and music clip A ended, has it ended, and then finally it gets to this tick and sees, yes, music clip A has ended. Now it's time. Now we know that it's time to pick music clip B, but the problem is that there has already been a little bit of time that has passed since music clip A ended, and so we get this gap. And so if you've tried to make an interactive music system, or if you've tried to concatenate audio together, you may have experienced this small gap. And the problem is that this gap is not even consistent, right? Because your video render frame rate could drift slightly. And so from playback to playback, you might get a different experience. So we have attempted a lot of approaches to mitigate this. So one of the approaches, which I'm calling unfashionably late, is basically where, okay, you know that you're late. Like you sort of accept that you're probably going to be late, right? So you're checking, has music clip A ended, has it ended, and then you're like, yes, it's ended. Now play music clip B, and your music is authored in such a way where a little bit of a gap, like a fraction of a second, is not going to sound bad, right? And so usually the kind of music that allows for this possibility is more fluidly timed music that drifts in its timing, sort of rubato music, or like aleatoric like music that has no strict timing expectations. And so maybe like horror music or something like that. And then also oftentimes you'll have a little bit of a tail, like a reverb tail, or music sort of tail off or trail off to help mask that gap. But again, it's still not going to be consistent from playback to playback. Right? The alternative to that is like, okay, well, on the game thread, I can evaluate, has music clip A ended, has it ended, and then I go, well, it's about to end. So maybe I know that it's going to end, and I think that the next tick is going to be more late than I am early, and so maybe I say, well, heck, I'll just start it early, right? So this would be like awkwardly early, and again, it just sort of the timing is necessarily requires music that supports, that unusual timing or unexpected timing, and so I think that this is even a less likely approach. You'll have fewer options in the kind of music that will be able to support this implementation. So these are the kinds of problems that we run into. Now, what I described in my solution last year was what I'm going to call fashionably late, which is to say you're going to be late and you plan on it. So you're not like, it's not like rushing out the door. It's like, yeah, we know we're going to be late, but that's okay. And so what I propose is basically a workaround to knowing that you're going to be late. And that is to say, okay, I'm evaluating my music clip A. Has it ended? Has it ended? Has it ended? Has it ended? And then I'm like, yes, it has ended. And instead of starting music clip B at the beginning, I know how long it's been since music clip A ended. And so then I can seek into music clip B and actually start music clip B later where it should have been, basically. And then as a trick, as a workaround, I mask the gap by incorporating part of music clip B into clip A. So that's what I have illustrated here. The problem with it is that even though it kind of works, the content you create ends up being complicated and inflexible, right? Because music clip A necessarily requires part of music clip B to be baked inside of it. And so this chunk of audio maybe can't be reused somewhere else because it already incorporates part of this sequence. So so you're limited in the kinds of content you can create, even if it is a more usable approach. Okay, so we have our problem, right? Our game thread is not necessarily when it's checking if music clip A is ended, it's not necessarily going to line up perfectly to start music clip B. So that's our problem. So the solution is that we need a higher resolution clock than our game thread update, right? And so if you can think of our game thread update as, our video frame rate, which is like, say, 30 frames per second or 60 frames per second, or even 120 frames per second or 90 frames per second, that can seem kind of fast, but musical timings, it's probably not fast enough, right? And so, and again, not necessarily going to be timed with whatever your music is, right? So, however, we do have a much higher resolution clock, and that is our audio rendering, right? So, audio renders at upwards 44,000 times per second. So instead of like 30 frames per second or 60 frames per second, you could imagine 44,100 frames per second or 48,000 frames per second. We have a much higher resolution clock, right? And so we can take advantage of that. And so in a way, you can think of the time synth as allowing you to bridge between the game thread and the audio render thread, which works at a much higher rate. And the way that it does this is through the synth component, okay? And so the synth component has basically two parts to it. A synth component has the scene component type part that exists on the game thread and operates with, interacting with gameplay stuff and operates as like any other sort of scene component. And then you have a DSP element that works on the audio render thread. Okay. And so what that allows the time synth to do is actually count individual samples. This is in audio, our individual samples is kind of like our video frame. Okay. And so it can count the samples, 44,100 times per second, and perfectly line up audio. That's the idea. Now, along with that, it has a sort of a metronome almost, and these are the event quantizations. So we have quantization events that you can think of like a metronome, and those work and operate independently of any sort of game thread timing, right? Those are true timing. And so let's say you have, so in our example here, going back to our illustration, right? We have our game thread problem, right? Has music clip A ended, has it ended, has it ended, has it ended. And then we can see that music clip B needs to start in between these two game thread updates. But our time synth is a much higher resolution. And maybe our time synth has several quantization events that it can take advantage of, right? So let's say this light colored one is our bar. It's like counting musical bars. And these dark ones are counting musical beats. So you could imagine, it has this sort of event update coming along, and it knows ahead of time, right? Because it's been scheduled ahead of time that music clip B needs to begin at this bar. And so even though it's in between two game thread updates, music clip B starts when it needs to start. So that's the idea. So if we were to walk through it, so imagine we have let me go back up real quick, make sure I don't forget anything. Yeah, so we have event delegates, that these quantization events on the time synth. And they generate event delegates on the game thread. So the game thread can actually monitor our timing, the time synth's sort of metronome, and then can make decisions on that, right? Because that's what we want. We want the game thread is where all of our gameplay logic lives. And so we need to make decisions there. And then we need to be informed by the game thread. So the game thread needs information, and then it needs to then come back and tell us what to do, basically, right? That's how we want the interaction to work. And so you can imagine that, let's say this blue, this blue guy is our little timeline element. And we can say, okay, we've hit our bar event on time synth, or a measure event on their time synth quantization event, and this sends a delegate to the game thread. And so now the game thread knows, even though it's a little bit behind, because the game thread has its own timing, even though it's a little bit behind, the game thread now knows that a bar has happened. And maybe the game thread has been counting bars. Let's say music clip A has 4 bars and then 1 bar of sort of reverb tail. And so those 4 bars, and we've gotten to the last bar, and the game thread knows we now have reached the last bar of music clip A. So we know in advance that it's going to end, and it's time for us to make a decision about what music clip B is going to be. And so we make that decision, and then the game thread says, okay, time synth, on the next bar, I want you to play music clip B. And it sends that to the time synth. Now the time synth ingests that and says, hey, okay, now music clip B is scheduled on the bar. So then it's counting its samples. It goes to each of its, another beat goes by. It says, anything scheduled on this beat? Nope. Okay. Then another one. And then it's like, okay, now we're on a beat and a bar. Anything scheduled on the beat? No. Anything scheduled on the bar? Yes. Music clip B. Okay. Start playing music clip B. And then it renders music clip B out as it's counting its samples. And then music clip B is playing. And so that's basically how the time synth works. Okay. So hopefully everyone got that. There'll be time for questions afterward.
Yeah. No.
And I'm going to continue going through this. But I forgot to mention that there is or should be soon a project that you can download, which I will show at the end of this slide deck, or near the end of this slide deck, where I'll actually start showing, demonstration stuff. But so you can download that hopefully soonish, and if not now, from the forums, and start following along.
Yeah, it's available
But
on the forums, as well as I posted a link in chat as well to both the slide deck
Oh,
and
awesome.
the video
Sweet.
and the project. Yeah, and it's live on the forums.
Excellent. Okay, so the TimeSynth is, like I said before, it's early access. It's available in a plugin. So if you download 422, then it will show up in the list of plugins. And you can kind of see it here behind. It's actually behind my head. It's right here. This plugin right there.
There we go.
Yeah, there you go. Sorry. That should have been a title safe image. Yeah, so the TimeSynth, so you'll want to enable that. Now, we recommend, if you haven't done it before, I'll link to the forums. You can check out the forums on doing this. But we recommend enabling the new Unreal Audio Engine, which we sometimes call the Audio Mixer. That's the Audio Mixer module. And basically, the new Unreal Audio Engine is something that we've been that's been in early access for a little while now, and it's awesome. And the only reason I recommend it is, even though the TimeSynth works both in the new Unreal Audio Engine and in the legacy Unreal Audio Engine, the legacy one, we just haven't had a lot of time. I haven't done any testing. Like I said, this is early access. It's very new. So I've only been messing around with it in the new Unreal Audio Engine. So there might be some unforeseen implications using it with the old one. So we just recommend using it with the Audio Mixer for now. Anyway, the Audio Mixer is awesome. If you haven't checked it out, you should just use it because it's awesome. Okay. So this is where you enable it. It's an audio category. So it's a synth component, and once you've enabled it in your project, if say you add a new Blueprint actor, then it will just show up in the component list. And what's cool about it being a synth component is that it's like any of our other synth components. It's spatializable, so you could potentially have like strong timed music or interactive music like in the world space, which is really neat. And it, all the other stuff you can do, like attenuation and using it with our submix graph and source effects and so on and so forth. So it's a cool approach. So as I mentioned before, the TimeSynth has these event quantization clocks. And so essentially there are a couple ways that you will set quantization on your TimeSynth. You'll either set it in the TimeSynth properties, or you will you can actually define it with a function in runtime. And it lets you set beats per minute, your beats per bar, and beat division, which is like your 4/4 or 3/4 or 5/8 timing or whatever. But the beat division is more like what gets the beat, right? Then an event buffer, just a little buffer. So if you got a pile up of events, and then a quantization. And the settings could be, if you're setting it for the TimeSynth itself, this will be global quantization, which means that there's like a clock that's just assumed, and then anything can use that clock. But if you're playing if you're setting your own clip setup, which we'll get into a little bit later, you can see that you can actually override that and have clips have their own quantization, which is very cool. There are a few ways to play a clip, a few ways to stop a clip. Sorry, one way to play a clip, many ways to stop it. So when you play a clip, you can indicate which clip and then you have an optional volume group you can associate it with, and I'll talk a little bit about volume groups a little bit later, and it will return a little handle to that clip, which means that you can reference it later on. So this allows you to say later on, if you wanted to stop just one of the clips that you've got playing, because you could play several at once on the time synth, you could stop just one of them, or you can stop a whole group at once by associating them with a volume group. You can also set a volume group's scale, and basically what the volume group is it allows you to associate a whole bunch of clips together and then control their volume as one group, to scale their volume as one group. So if, say, for example, you had a bunch of drums and then you had a bunch of, bass, you had like a synth bass and you had some trumpets or something like that, then they could each have their own volume group, and then you could control the volume of those groups as one, or as a group, or etc. So that way you just have, this is, like I said, it's kind of like a miniature audio engine. So it's got a lot of sort of simplified audio engine features, like mixing, starting playing sound, stopping individual sounds, or stopping groups of sound, that sort of thing. And then here's the function where you can add event delegates. What's cool is, so like, for example, if you need to receive events, let's say on like every time the event quantizer hits a bar, you want your blueprint to know about it, right? Or your gameplay to know about it. Then you can set up a event delegate, right? And so you just add quantization event delegate, and then you can tell it what type of quantization to alert you of, or to execute on. And you can have several at once, which is very handy. And then you get some basic information, quantization type, the number of bars or the beat, etc. So you get a little bit of information about your state. All right, and then clip, which we'll get into a little bit, we can get into a little bit deeper a little bit later when I actually bring up the demo. But basically, it's a new asset type that's associated with a time synth, and it wraps sound waves and a bunch of playback like behavior data. So you can say, for example, in this clip, I have under sounds, I actually have 6 sounds in an array, and each element in the array has a reference to a sound wave, a weighting. So this, whenever this clip plays, it will randomly select from this array, which is cool. You get randomization right away, very easy. And then you can give different weightings to elements. And then it also allows you to do switching based on distance from the listener object. So we actually, this is something that we're really interested in seeing the time synth used in also non-music ways. So we see it like, for example, a machine gun is oftentimes, like, if you have a high frequency machine gun shot, then oftentimes you'll author the content as a loop, because the sound of it has to stay consistent. Humans are better at hearing inconsistent timing than we are at seeing inconsistent timing. And so when we get frame rate drift with like automatic weapons, the sound is kind of a tell that the frame has drifted, whereas it might not have been noticeable just looking at it. And so oftentimes, as a sort of trick, sound designers will author high frequency machine guns or assault weapons with loops, and then play a one shot when they're done, when they like stop firing the weapon. But there's a lot of problems with that approach. One of them just being like, as gameplay is as you're developing the game, people might want to change the timing of fire playback, right? Because maybe it's a balancing issue or whatever. And so then you have to go back in and re-author the loop, and it's kind of painful. We think that the time synth could be used for like high frequency weapon playback, which could be really interesting. And so, so yeah, there's opportunities there, or future we see as potential. And so maybe you want to switch the sound based on distance. That's something we use in guns all the time, but it could be for anything, right? Some fade out information and some timing information, like the clip duration, and then this is the clip's like own quantization. So it defaults to the global quantization on the time synth itself, or it could have its own. So in this example, for this cue, I had the global quantization on bar, but this particular clip could play on any quarter note. And so I just put its quantization to quarter note. All right, so let's play a video. Let's play the basic one so we don't overwhelm anyone.
All right, we're getting it queued here.
I can see it. I can't hear it.
Situated here. Should be able to get audio. There we go.
All right. Cool. You got to hear the seamless loop. So yeah. In this example, I'm basically showing all right. So I'm showing essentially that you can start and stop a clip. And so if I'm just going to go into the project real quick so you can see what that is. So basically, when you open up this project, and if you go to the basics directory, there's a prototype directory, a basics directory, a completed cue directory, a music directory, and a volume groups directory. If you go to the basics one and load that level, then you can actually try this demo out. And essentially, what this is the basic implementation of making a loop, starting it, controlling when you start it, and controlling when you end it, and having the quantization of the time synth and the end, the call to stop this sound, be different. So if we look at the implementation, is actually not too complicated. I think what you'll find with any sort of music system is that a lot of state management happens, right? A lot of music systems are state managers. So that's what you'll see a lot of the more complicated or nitty-gritty parts of this. But here you can see I have my actor. There's a time synth. I've already set its quantization settings for my cue up front here. When I start the begin play, I just say, hey, am I going to play with an interface or not? And this is where I launch the control interface. So we won't go into that. I mean, you can try it. You can check it out if you want on the project. But mostly it's the magic starts here, where the interface says start the music. And I just check, again, state. I just check, is music playing or not? And if music is not playing, then start. And if music has already started playing, then this button will do nothing. Then I initialize some state. Zoom in here a little bit, see how that looks on the screen. Yeah. So I initialize some variables, just everything that you need, the way things need to be set when you start out, basically. And then I set up my event delegates. And if you haven't used this is pretty handy. Basically just allows you to assign an event via distance.
Yeah, without
So,
spaghetti.
yeah, exactly. It cleans up some of the spaghetti. So this is setting up my bar event, quantization 1 bar, and this sets up my beat event. So that means I'm going to get execution every bar, and I'm going to get execution every beat. And then the last thing I do is I swing down over here and I play my clip, right? Because I had been told to start playing. And so I just play it right away. And I have my clip assigned here. And then I didn't have any sort of volume management, so I didn't need to associate it with a volume group. So I just left that. And then I cached my clip ID so that later on, if I wanted to stop that clip, I can. And then I just set some state. I say, okay, I've queued my clip. Now, this is what's important to remember is that this function is scheduling the clip to play. And the clip uses the time synth's quantization of 1 bar. And so that means whenever this is executed, it says on the next bar, play this clip. And then the on bar event can execute here. Right. So I said that the main loop is queued. So on bar event executes. It says, hey, is music playing? Yes, it is. Remember, we set that right here. Music is now playing. And then I have a sequence node that I didn't end up using. And then I say, hey, has the main loop been queued? If it has, then it has started, because I assume that because this has been queued, that the next execution, it will actually have started because it was on the next bar. I scheduled it, right? Cool. Then on every beat, I just cache which beat I'm on. And then I check, hey, has the music loop actually started? So this is remember, I am basically at this loop state is basically me realizing that the playback is no longer queued. It has now started, right? And so now that it has started, I can begin beat counting, and that's what I do. I'm just beat counting. I have hard coded the length of my loop. I know that it's 8 bars long and it's 4/4 timing, and so it's 32 beats. And basically, I just take the main loop count and I mod it against the loop length and I increment it, right? It's +1, so I'm incrementing it. So every time this executes, it's saying, okay, next beat, next beat, next beat, next beat, next beat. And then when my loop length is, when my current loop count is greater than my loop length -1, I schedule the clip on the next bar, right? So I call that again. So that basically means when I am 1 beat away from finishing this clip, trigger the clip again. And then our sequence node is just update our progress bar. And this is just for the UI. That's how I set the progress bar. It fills up that progress bar. So that's not even important to the actual. It's just for the visualization. And then when we click end music, we check, is the music playing? Because if it's not, then we don't need to end anything. And then we just say, stop it. And we call the stop on our clip ID, which we had cached earlier, remember? And then we can actually override the event quantization. So we can say stop on the next beat and give me a 1 beat fade out. And then we update some state. Music is no longer playing, and the main loop has no longer started. And that's the simple one. So that's like if you're looking for just I want to be able to start playing and I want to stop playing, then it's as simple as saying, okay, you just need to know when you're playing and when you're not playing, right? So you're just keeping track of your own state a little bit. You know more about your music than we do. So you start playing your music. If you're looping it, then you need to count, or you can technically just play a looped sound wave. That's fine, but I like to do retrigger because it lets you bake in tails to your nice reverb tails. Okay, so let's play the other video. So this is the completed cue, and this is kind of like. So we've got some concatenation. We have multiple layers. Beat synchronous hits. Beat synchronized melodies. The melodies actually have multiple layers as well. And then we could end our cue with a big finish.
That's awesome.
So yeah, so there are a lot of things that I show off there that are sort of bread and butter for interactive music systems right now, and that is, having, say, multiple layers that you can switch, sort of modulate between, which we sometimes call horizontal layering, and then there's slices and different approaches that you might take with slicing, but usually it's like I said, I like to leave a little bit of overlap where the tail can sort of continue going. In this case, for the ending cue, I actually overlap the beginning. So there's like some swell in that helps mask the transition because I want it to happen at any bar. There's so much you can do with this and so much farther you can take it. And I don't want to say that this is how an interactive music system should work, because the idea of the time synth is that you can make the interactive music system that you want to make, right? It's just the piece of, it's just the piece of like technology that you need to have strong timing on your playback. And so if we want, we can look at the completed cue. But I would encourage you to sort of explore it and try it out, download the project and play it. And I've tried to comment everything, but most of it is, like I said, it's just taking the next step in like managing state, because there's like a lot more stuff to manage. I would probably say if I were to create a more generalized system, because this is built very much around this particular piece of music, if I was creating a more generalized system, I would probably try to come up with a more elegant state management. Here I'm using a lot of bools, you can see, but it probably would be more elegant to have, say, an enumeration for each clip. But basics, the basics are still there, right? We start the music, we set up our event delegates. I just set some initial volumes because I have multiple volume groups now. And then I have my clips and I play my intro. And then I just determine when the intro is done playing. You can see here, again, I'm doing that like same stuff you saw before. I'm updating state information. Every bar, I'm sort of checking to see if I need to update state information, determining whether or not it's time to re-trigger the main loop. And then triggering the loop is just playing 2 clips because there's a low intensity clip and a high intensity clip. And then I just update state information, and I'm caching these just like I did before. It's very similar to the basic one. It's just taking the next step. And then I just have that one little bit that's like, okay, are we trying to end it? And then we mark the music. The mark is when we say end the music. We look at the end. Where is it? There's the play melody. Where did I put end? End music. It just says, hey, are we playing, and are we not already trying to end it? And then we just mark it for end. And then I just check for that every bar. Oh, is it time to end? If it is, then we need to start playing. We need to schedule the ending clips to play. And then because I wanted an overlap, I have to wait 1 extra bar before I stop the main loop. And that's what happens there. The drum accents are super easy. These are simple because they just play 1 clip. And it's just like, I just check, is one already playing? And if it's not already playing and the music is playing, then you're fine to play. And basically this is just every time, because I didn't want to overlap clips. I didn't want to have the drum accents sort of sit on top of each other. I wanted to make sure only one was playing at once. And so that's what this is all about. This state management is just like, I just want to make sure only one plays, and then every beat I reset that and say, okay, you're allowed to play another one. You're allowed to play another one. And then playing a melody is just checking a lot of state because I only want the melody to play, during the main loop. But yeah, so it looks probably a little more complicated than it actually is. The melody, I did a couple of things here because I didn't want the melody to repeat. So I actually have 3 variations on the melody, and every time you play it, I just cache which one, and then I make sure that the next time you pick randomly that it's not the last one. So that's just a quick implementation of like making sure we don't repeat the last melody picked. So there's always slight variation every time. And then the melody plays. It's very similar to the only thing about the melody is a little bit different is that I actually wait for a specific beat before I cue it because I don't want the melody to play just at any time. I want it to play on a specific phase of the bar. So it actually plays, I think, on beat 2 or 3. Yeah, I think it's 2 actually.
That makes sense.
But the beats go 0, 1, 2, 3, so it'd be 2. Yeah. So that's sort of a brief overview of the more complex one. Now, for the adventurous, real quick actually, you can see the music. So here's all my sound waves for the music cue. So this is what I brought from my DAW. And then here's all the clips defined. And most of these just have 1 clip, but you'll notice that, say, like the drum accents, that's what I had up before, has 6. And so it just randomly selects, every time it plays, it randomly selects one of these. And I didn't worry about the drum accents, repeating. That wasn't important to me. I also didn't do intensity layers for the drum accents, though I could have. But yeah, I didn't think it was important. So and then volume groups. And we just have 2. We have a low and a high. If you're feeling adventurous, you can see the prototype actor. This is the actor I actually used. This is actually where I built it. This is raw Dan. So if you want to see like the unclean version, then you can see the unclean version. There are no comments. You're on your own. This is like a peek into my mind. But you'll actually see a lot of repeated things.
Choose your
and like
adventure.
I said, I think if I was planning a more generalized system in advance, I'd probably come up with a more elegant way to manage state than all these bools. But yeah, so definitely encourage you to download the project, try it out, play around with it, poke around with it. And if you wanna like practice, you could take maybe last year's music and try to use the time synth instead. It could be interesting, you know. But even just anything, if you got your own music, that'd be awesome too. I'm excited to see what people come up with. But anyway, so let me pull my slide back up real quick. One or two last few slides. So things to be aware of. So once again, the time synth is in early access state. And that means this is something that we're excited to develop. We see it as something that a lot of people, this has been something I think a lot of people in our community have been waiting for. And we want to keep working on it. We see it as sort of like in an early state. We think it's usable for certain applications, but there are things that you should be aware of coming into it. Again, this is not specifically a music system. This is a tool for creating your own music systems. And kind of what that means is up to you, which is awesome. I think it's awesome. Anyway, so at the moment, when you play a new clip, when you schedule a clip to play, the scheduling is limited to the next version of that quantization. So if you're like, play this clip on the bar, it's just going to pick the next bar. Play this clip on a beat, it's just going to pick the next beat. So the thing that's sort of the gotcha is that if you're trying to do something with like super tight timing, you may get some unexpected results because you're still executing your play logic on the game thread, right? So like if your musical timing is shorter than the game thread, then you're kind of so you'll see that like my approach has been so far just to always use something like bars or beats as my quantization boundary, because I know that my game thread is going to be I'm gonna be able to predict in advance when the next bar is, when the next beat is. I think it's gonna be harder on something like the next 64th note or something like that. So that's something to be aware of. So if you have major game thread hitches, it can still throw off the timing expectations, right? So if I had some like crazy hitch in the game thread, then it's possible that my drum accent wouldn't have hit on time. So it would maybe it would have ended up on the bar or the beat after the one that I had hoped it would have ended up on. But that's just like, you know, that's runtime games. Like there's nothing you can do about that. Like the game thread hitching is maybe you should address that. It's like the problem is not at that stage, the problem is not your music system. The problem is like your game thread should probably not hitch for that long. And then care should be given to avoid double triggering or triple triggering or quadruple triggering clips. When we first started prototyping with it, I was accidentally double triggering clips, and because the playback is sample accurate, the audio is perfectly aligned. So you actually get two copies of audio perfectly aligned, and you get absolute construction. Basically, it just doubles the volume for two, and triples the volume. So that like perfect alignment is its own little double-edged sword if you're not taking care. So that's why you saw things like, you know, a lot of flow control with my bools in the system for like the drum playback and stuff like that, because I didn't want I didn't want the user to be able to trigger two drum hits at the same exact time in case it would be the exact same one, because then it would just be extra loud. So that's those little things to know. We see a lot of opportunities in where we can take this feature. We're really excited about the kinds of things, and we like some of the we talk about you know, where we can take it, where we can take the time synth, and some of our ideas are more or less reasonable. Some of them are more realistic or less realistic, or more likely and more pie in the sky kind of ideas. But some of the things that we've thought about, these aren't. This is not a roadmap, but some of the things that we thought about are like end actions. It would be really cool if at the end of a clip could maybe play another clip or something like that. So that's where like you could take something like a high frequency machine gun. You could actually have a shot that like you could have maybe two shots that are like close together, that maybe the timing is even tighter than the game thread timing, and then the clip itself could automatically play the next clip, et cetera, et cetera, et cetera, et cetera. We think maybe like being able to define the timing data in a clip with different timing nomenclature, right? So right now we're using, bars and beats because the time synth was prototyped last October around a sort of music problem that we were trying to solve in an internal project. And but I could see, timing clip timing data being defined in maybe seconds or even samples because it's sample accurate. It'd be cool to see something like a clip quantization offset. So I could imagine, being able to say, oh yeah, we want this piece of music to play on the bar, but we want to offset it by like 1 beat, maybe plus 1 beat, so it's delayed by a beat, or maybe it's like minus 1 beat, so it's maybe like always around the bar but a beat early. That would be cool. That would make certain things a little bit easier to do in like flow control. It would be really cool if we could somehow synchronize multiple time synth components, maybe link them together and have them share quantization clocks. We think that'd be really cool for like crazy installations, music installations, or interactive music installations, or like I could imagine like a virtual reality band where maybe each of the players is like dynamic music system, and but they're all linked to each other, and so that they're all timed together. That'd be really cool, and spatialized inside the world. That'd be really cool. It would be neat to. So some of the stuff on the right's a little bit less like it's a little more ambiguous, like how those would be accomplished. We see like could be interesting to have dynamic clip creation for maybe procedural clip generation. You could see like an application where maybe users could record their input on top of existing music or something like that, and then it would automatically create that as a clip and then synchronize it or help you synchronize it, or you could synchronize it as a user or something like that. Some method of defining sequences of clips, so we see that as like a something that is desirable. Not always having like to say, oh well, on the next beat, on the next bar, on the next beat, or whatever, but being able to say, okay, 3 beats from now, or it could also be cool to maybe there's some way to say, let's say you've got a bunch of clips that are all like single drum samples, and then you could like procedurally generate a drum pattern for a whole bar's worth of music, and then just sequence that up front. That'd be cool. Editor tools or workflow, little things to help. This is sort of ambiguous, but we would like to see maybe something like that in the future. And we also, so this is more of a pie in the sky thing, but we think it'd be cool if maybe you could bring your music in and then have it analyzed for beats and onset analysis, and then it like automatically generate the clip or something like that, the clip data. I don't know. So those are some future land ideas.
Future
Yeah, like it's
love it.
I think the time synth is kind of it inspires this kind of thinking. So anyway, so that's my talk. Some contact information. So if you want to check out more about the Unreal Audio Engine, the new Unreal Audio Engine, or if you just want to like see what's going on, Check out the forums. We have a small burgeoning community of people. I always put this on my slides, but it's not an Epic thing, so I don't know if it's not like an official Epic endorsement. I don't think, but I endorse it, and that is this game audio implementation book. So if you're new to UE4 audio, then this is a pretty good starter book. It's a little bit old, but it's a good resource to start out with. And then this is my Twitter @Danther, and that is an approximation of my face when I'm happy. So yeah, that's it.
Yeah, thank you so much, Dan. That's great. We got plenty of
I hope
questions
you're ready
here.
for some questions.
Yeah.
Yeah, let's
And we
bring
got
them
some time
on.
left to do it. Yeah. So one of the first things they were wondering was how much the time synth affects overall performance.
It's just like any other synth component. The only thing that you have to be careful. So the time synth on your voice budget is a single voice, which is cool, but it's a bit of a cheat because you can render a lot of audio on a time synth, which means that you could technically cheat a lot of voices with the time synth because it's like a miniature audio engine. From a performance standpoint, I would not expect more of a burden than playing that audio normally.
Okay.
Because all it does is it just decodes audio. That's all it does.
Yeah, essentially, it's not taking 44,000 times or making.
Yeah, exactly. So so audio rendering does look it. So like it's not like you're executing your logic every sample update, right? So every sample, you're rendering audio. That's just how an audio engine works. Like audio engines run at a very high frequency, right? They have callback buffers, which if you look in the settings is defaults at 1024 samples or 1024 frames. I think it's 1024. I'll have to check on that. But basically, it renders in chunks and then hands those off to the audio device, your computer's audio device or your console or whatever. And so rendering in those chunks, that update is actually much slower. The time synth allows audio to begin playing in between those. So it's actually more accurate in that way than playing audio normally. But that's the idea of it, right? That's the whole point of it. Otherwise, it's just decoding audio. So I would not anticipate a lot. I expect you'll probably end up finding more of a performance situation with whatever your wacky music system is going to be. Like, that's what I would not expect it to be super crazy. Unless you're playing a lot of audio on it. Like I said, it could be, you could be cheating a little bit.
Right, but that wouldn't necessarily be the time synth. It's just the fact that you're playing a lot of audio.
Yeah, exactly. Yeah. So yeah, it's early access. We haven't really had a lot of. It's not like we've done performance tests or evaluations with it. So it's kind of new. We haven't. This is my expectation. This is speculation in a way, but I don't see why it would be a particular burden.
That's great. They're a little bit curious if this will tie into particle systems in any way. If there's a chance that you can essentially, I believe the exact question was, future versions of Unreal, will they have sound particles plugin or implementation?
Well, so that doesn't sound like a question about the time synth, but I would check out the granulator, which is another synth component. That is, a granulator is, or granular synthesis in general is basically the audio analog to a particle system. So I would check that out, and you'll want to maybe hit up our forums where you can look at adding that. And I think I have on my big sticky, I have a very brief overview of the granulator, but yeah, that's probably the closest approximation to a particle system that I can expect. However, with the time synth, because gameplay is receiving timing data, you can actually have music playing or whatever the time synth is doing, actually spit out event delegates to the gameplay that say like a beat. And so you can actually have particle systems that are driven off of the beat.
That
Pulse.
was precisely what I think next question was about, where they were asking if it's possible to use something like markers on an audio timeline, similar to how we do event notifiers in the animation blueprint.
There's no timeline per se, but that could be an interesting. I actually like that idea. That could be an interesting future feature, where maybe you have on your wave file like a marker, because you can embed markers in wave file data, and I can imagine maybe having the time synth interpret markers as like an event that it sends maybe the marker labeled to an event, so you can on the gameplay maybe say, oh, this marker's splash played or something like that.
Yeah.
So yeah, that'd be cool.
Yeah, that'd be great. I'd like to have that as well. They were wondering what the difference between a volume group and a sound group is.
So let me make sure. Let me just load up. Maybe it was premature in unloading the editor. I just want to understand. Maybe I just want to verify that. I think they're talking about this parameter called sound group. So if you share my screen real quick, and if I go to the music, the sound wave. Where is it? I never look at this. There it is. This sound group parameter. This one right here. So this sound group has nothing to do with the time synth. This is an older like legacy grouping mechanism that allows you to basically it allows you to control whether or not these sounds are fully decoded on load or real-time decoded. So if you go into into your configuration file, you can actually define. You can say like, oh, sound group let's say sound group effects. If they're less than 5 seconds, then we fully decode on load. If they're greater than 5 seconds, then we do real-time decode. So real-time decoding is a little bit more CPU intensive, but it saves on memory. Decoding on load is means that the entire, so all of your wave files are compressed. All right, when you cook the game, they live in a compressed state, and they're decompressed in order to play them back. Right. And this process we call encoding and decoding. When you're loading a file, you have the option, because you have to play it back. Let's say you have to play it back. Well, you could decode the entire file, or you could decode little pieces of it at a time. And so it's more than likely that longer files you'll want to decode pieces at a time, because you don't want it to like sort of flood your memory. Because honestly speaking, you don't need all of that audio in memory at once. The only thing is that, like, so if you imagine like this comes from the era of loading screens. Like this system sort of is from the old days. And so fully decoding on load makes more sense in like a game where you're loading up the whole like arena or whatever. And so you've got like a loading screen. You imagine a loading screen, and it's like loading up all your footsteps and all your gun sounds and stuff like that. And those are being fully decompressed into memory. So that's what the sound group is. It has nothing to do with the time synth. Volume groups, as I mentioned before, are they're specific to the time synth. They're only for the time synth, and they're just a way to manage the volume of multiple clips at once. That's what they're for.
It's great.
So you can think of it as like a mixing mechanism.
Detailed explanations there. I didn't actually know about the sound group, so
Yeah,
or
no one
that we
does.
could change it. Yeah, they're curious, sort of. They're using Fmod, and they were wondering if this can replace it.
So, okay. Here's the deal. So what Fmod is an audio middleware. It's its own engine. It's its own audio engine. And the thing that I feel people need to fully appreciate is that middleware like Fmod is never going to be more like, no one is going to be Fmod like Fmod.
Mm-hmm.
All right. No one is like, if you want Fmod, then you got it. Like it's there. It's Fmod. Like, use it. But I think you have to really ask yourself. Like, that's not a question that I can answer, because what you have to ask yourself is, why are you using Fmod, and why do you want to not use Fmod? And if this is satisfying your needs, then that's the question. That's the question you have to answer, right? I can't answer that for you.
Yeah, it depends what you need the tool for and what you're expecting it to do. I was just saying it depends what you need the tool to do for you in your specific project, right? And what
these are all just tools, and like I said, this is our way of doing things. This is the Unreal Audio Engine. Fmod has its own features. Wwise has its own features. CryEngine has its own, like Crytek has its own features. Miles has its own features. Like, all these audio engines have their own features, their own way of doing things, their own workflows, their own pros and their own cons. And each individual one is itself. It's not replaceable with any other one. It's going to be a different experience every time you move from one thing to the next. And so I personally, it's part of why I have this job, is because I like the Unreal Engine. Mm-hmm. I like working in the Unreal Engine. And I don't necessarily want to work outside of the game engine. I think it's fun to work in the game engine. So to me, working in using the Unreal Audio Engine is satisfying, because I am deeply connected to all the other things. I'm connected to artists. I'm connected to designers. Like, I worked on Chaos, and so, like, I was able to, coordinate things with the game designers very specifically, and I was able to go into their blueprints and then sort of learn them, decode them, and then figure out where I could tap in the ways that I wanted to tap in, and that was liberating, right? I didn't have to wait for some game designer to, like, create a hook for me. Mm-hmm. So I think you have to ask yourself, like, why do you need this tool? And I've seen surveys in, like, informal venues like Facebook or whatever, where people are like, why use native? Why use middleware? And overwhelmingly, the consensus is that the people tend to use middleware because it's what they know. But that's up to you. Like if you learn a system and you become really good at it, then you know that too, and you can make an informed choice. But if you don't know how to use the Unreal Audio Engine, all you know how to use is middleware, then you can't make informed choices about which one you're going to choose, right? So I would suggest learning everything.
Right. Do a bit of experimentation and try it out.
Yeah. And then you have to answer those questions on your own. And they're not always going to be the same per project. You'll find, like, as you move from project to project, that the project needs demand particular things or particular workflows. So
they were just, once again, and I think it's worth repeating, which plugins they need to activate. And that's the TimeSynth and the new Audio Engine, right?
So so in this project, I activated a couple of plugins. I activated the TimeSynth plugin. I also activated the synthesis and DSP effects, and I activated sound utilities because these are two things that I like to add on projects using the Unreal Audio Engine, the new Unreal Audio Engine. Now, for activating the Unreal Audio Engine is actually much simpler than it used to be. So here's the project directory. If you go to config and you go into default engine, you can see here, there. Let me make this
Not tiny.
so you can see. It's simple. How do I like zoom
Can you
out?
do just like Control Plus?
Context. Basically,
Nope.
use audio mixer equals true. I don't think you can see that. That's pretty awful.
I think it's part of the documentation.
Well, yeah, it's yeah. Anyway, it's just in your engine directory. It's just use audio mixer equal true, and then it will load the audio mixer module. So
They were curious if
Oh.
quarter notes and eighth notes, are they built into the timer automatically or just bars?
So the quantization options, let's see. We'll just load up. So it's let's say we've got no quantization. Why not? We have 8-bar phrases. We have 4-bar phrases, 2 bars, 1 bar, half triplet, quarter triplet, eighth triplet, 16th triplet, 1/32.
That's
But
pretty much
as I
it.
said before, it's always going to be scheduling the next one. So the game thread, if the game thread is slower than your quantization, then it may not be the one you were hoping for. That's all. That's just something to watch out for. And there's nothing we can do about that. That's the game thread. That's just the game thread.
Is TimeSynth functionality available through C++ as well?
Yeah. So you can, if you go to our GitHub release, then yeah, you can see the TimeSynth code. You can look at the module.
I think they were also asking.
I think in fact, because it's like a miniature audio engine, if you're a student, this is a great learning resource because you'll basically see like a miniature audio engine in action.
I think they were also wondering if there's anything exposed through C++ that's not available in Blueprints, or is it on pair?
I think pretty much everything's out there. There are some things that I didn't talk about because but those are more specific. Those are things that sort of I don't know if we're going to keep in the TimeSynth because I don't know if they're relevant anymore. So when we were prototyping the TimeSynth came from a prototype for a project, an internal project.
Mhm.
And in that project, we weren't sure if we were going to use the new audio engine or if we're going to use the legacy audio engine.
Gotcha.
And so it works on both technically, although I haven't been testing it on the old one or the legacy one, we call it. But it also has things that are now part of the new audio engine anyway. So like it has like FFT analysis and it has some filters and it has a compressor. In fact, the compressor, when I was working on this project, the compressor, a Dynamics compressor, it was hard coded for some reason, probably something I did, to like really non-ideal settings. It was much too aggressive, which probably worked for the project that we were prototyping on, but not for this particular piece of music. So we're actually going to hotfix on 422.2. The compressor is going to be much more relaxed. And if you're testing this at home, the videos that I played are actually recorded with that change, but the change hasn't gone in yet. So when you're testing at home, you'll see it. It sounds a little bit different. But yeah, so like those things aren't really needed with the new audio engine because you have source effects and you have FFT analysis already. So envelope analysis, that sort of thing. So yeah, there's definitely stuff in there that I didn't talk about, but I don't know if anything's specifically exposed to C++ that isn't to blueprints.
It's pretty good.
I mean, there's a lot that happens behind the scenes that's just
Yeah.
part of the component itself. But
is there any way to debug currently playing sound samples?
You mean like in the editor?
Yeah, I think they were wondering if it's possible at runtime when the game's running.
we don't have like a view inside the time synth right now. So it's a good question. It's definitely one of those sort of future feature things.
Yeah, because in case you were playing double or triple trigger, and you'd be able to see three samples being played, right? Yeah.
Yeah.
Um,
but that's stuff that you could technically build into your blueprints, because all that logic lives in your blueprints, presumably. So you could, I don't know, put a counter for every
make
time
a little macro that also, prints something. Yeah.
Yeah, exactly.
Can you only have one time synth clock running at a time?
No, you can have. I mean, the time synth has its own clock, but every time you can have multiple time synth components. That's why one of our future feature ideas is maybe some way to synchronize multiple time synths, because you could probably, if you set them up at the same time, then they'll probably be timed the same. But I could see situations where you have a time synth going and then another time synth comes in and you want it synchronized. That would be harder. So that's one of the things it would be cool to be able to link them or something like that, share them or something like that.
Is there a way to run this asynchronously from the game thread in order to avoid hitch issues?
So let me be clear. The time synth, there's the blueprint sort of, or the gameplay component of the time synth, right? The time synth component. And the component has an API to gameplay that is for game thread calls. The actual rendering does not happen on the game thread. So the time synth is not going to be affected by game thread hitches. The time synth playback will continue. The problem arises when you, on your system, on your music system or your whatever system, try to schedule a sound and there's some major game thread hitch that schedules it too late. That is a gameplay problem. So that has nothing to do with the time synth. It has everything to do with blueprints. So that's not, like I said, the time synth is not going to be interrupted by game thread. Like, that's not the case. Your music system, which lives on the game thread, that does all of its logic because it's taking in game event data and state data and making decisions about where the music should go next, that can be affected by the game thread. And honestly, it's only an impact if your game thread hitch is longer than your quantization boundary, right? So like I said, if you're like, I'm on the last bar of my music and I know I have to schedule another one, like if you have a game thread hitch that is a whole bar long, like you're in serious trouble, and it has nothing to do with the time synth. Like you need to stop working on the music and you need to start fixing the game thread problem that you have. But the time synth will keep playing. It'll just keep playing. So.
Any chance live audio metering is on the way for monitoring audio levels on the fly / at runtime?
So we already have envelope followers in the new audio engine, and FFT, real-time FFT analysis on submixes, and you can do submix. So like, yeah, we've got it. Like, so the future is now.
Sorry to hear. Can the time synth play sound cues?
No.
It cannot. Nope.
No, and it probably never will. I can't see it. The sound cues are not. there's nothing about the sound cue logic that intimates sample accuracy. Like it's its own thing. I don't see it. No. I mean, maybe Aaron's can think of a way, but I don't know. I don't see it.
We're also wondering if you have plans to support list permuting for clips. Would be great to have any easy toolbox for list manipulations, scramble, shuffle, Euclidean, De Bruin, gray code, etc.
I think just in general, I could see that as an Unreal editor tool. Like it's a little finicky to work with multiple element data types like arrays and maps and things like that. I think I would like to see. It would be cool to see more editor features around that. It would be neat to be able to say like grab a bunch of data types, say like from your browser, and then be able to drop it on an array and just automatically populate the array with all those. That'd be great. So I think there's a lot of opportunities for that sort of editor workflow stuff, but I don't see them as exclusive to the TimeSynth. I see them as like just general cool stuff for the editor.
What kind of headphones are you using?
These are Beyerdynamic 770s. They're all right. They're kind of new.
I think someone in chat got it right then.
Yeah.
Yeah. Do you have plans to implement live audio input so that we can interact with real-time audio stuff?
We have it. It's called the audio capture component.
Look at that.
So you can. Your future is now.
Yes.
Yeah.
Check.
Now.
Next. Is there any way you know of for recording and exporting waveforms during runtime?
Yeah, we have it. It's a submix
Check.
recording feature. Check. Future is
Next.
now. So you got to go to the. This is why you need to go to the new Unreal Audio Engine. So this is all available in the new Unreal Audio Engine, and you can set up a submix, which is a whole graph of submixing, and you can basically say record the submix output, and you can both it's really cool. You can turn it into a sound wave file, so you can actually turn it into an asset for your project, where it will populate a directory and be available in runtime to be used as a sound wave, or you can export it as a wave file for your user. So it's pretty cool.
That sounds great.
We're actually really psyched about using it for testing our audio engine here, automated testing and things like that.
To sort of hear what it sounds like once it's being played.
So that we can maybe like we would like to eventually be able to record, say like have a test play, and then record it, and this is like how it works when it functions, and then be able to maybe automatically run it later on, and then maybe do some sort of diffing between the two wave outputs to determine whether or not something broke. So the wave recording's cool. Yep.
All right. I think that's everything we got time for today, actually. Thank you
Nice.
so much, Dan, for coming
it was
on.
my pleasure. Thanks for having me.
Yeah, a lot of great information.
Absolutely.
Yeah.
Good.
Great, and chat seemed to enjoy all the questions and everything you got to show. And for everyone, the project as well as the slide deck are up under the little resources section of the announcement post. I'll make sure to link that in the end.
Cool.
And if you have any future questions for Dan, make sure you can ask them in the forum there, and we'll, as always, answer them if we can. And yeah. And for everyone, please fill out the survey. We can try to link it in chat again. We will pick a lucky winner from all. If you provide us your email, we'll be able to pick a winner, and we'll send them a T-shirt.
I went ahead and dropped the forum link in there, so that's where the resources and things you can access there. So.
Perfect. Yeah, and it's 422.1 shipped earlier this morning. Well, Eastern.
Awesome. Yeah, I just
time.
updated.
Yeah. I think some people in chat were doing as well. And then, as always, check out our user groups on Meetup. There should be a link, I believe, on our webpage that's easy to access.
Yeah, you can go to unrealengine.com/user-groups, or you can Google us on just Google Unreal Engine. But it's meetup.com/pro/Unreal Engine. We'll take you specifically there.
Yeah, and especially if you start working with a little bit of the new audio stuff, make sure you bring that to your meetup and
Yeah.
and show it off.
You could be the local expert on the, the
On
audio
the new
engine.
audio engine. Yeah.
That's right. Well, I'm
Uh,
psyched. I mean, I'm really interested in seeing what people do with this. So definitely, if you make something cool, yeah,
Yeah,
tweet me or something like that.
the VR ban has been in my mind for quite some time. There's still a couple of issues I have with sort of the virtual rehearsal space that I'd like to make, but that's mainly because of the latency over the internet. But
Yeah,
in-house
sure.
on a local
Nice.
network, that might actually be something that's fun
Yeah,
to
man.
do. Yeah, is that what you're saying? Next game jam, we're making a
Audio jam.
audio jam. Next audio jam.
Audio jam. All jams are audio jams.
Can be.
As always, remember to check out our online communities. We have a community around Discord on realstackers.org. It's great to ask for help or show the community what you're working on and us as well. And you saw we had a new countdown video this week. Yeah, we've actually been receiving a couple of them, so we're really happy about that. If you'd like to for us to show one of those, send us a 30-minute, take 30 minutes of your development and then speed it up to 5 minutes, and then just shoot an email to community@unrealengine.com, and we'll put you on the live stream.
Yeah, we'd love to see more in rotation. So
Ye-
please send them over. And it's a good way to promote your game and get some visibility and get people excited about your projects.
Yeah, and see what you're doing, the tools you're working with, and sort of a little sped up version of how you work with Unreal.
I was watching that video. Those mice were cool.
Yeah,
Those
yeah.
flashy mice.
And he also showed Blender and how to assign different materials to faces. So
Yeah.
that was great. And you see, you're able to catch a little bit of the workflow, even though it's sped up by quite a bit, which is always something like, oh, what do you do there? Pause, look, okay. I think Exodus is in chat actually, so you can ask him specifically if there was something you were
Yeah,
wondering
to go
about.
teach fellow people Unreal.
And if you're streaming on Twitch, make sure you add the Unreal Engine category so that everyone can see that you're working with the engine. I try to tune in a little bit now and then, see what people are working on. It's always fun to hang out there. And
I
make
do
sure.
too, actually.
Oh, that's great. We should.
Yeah.
And I know Tim's in those chats all the time.
Yeah. Hanging out. And as always, follow us on social media. Got Twitter and the internets of things. And as always, a huge special thanks to all of our sponsors, everyone in our community, our user groups, everyone who makes Unreal Engine an amazing tool and such a great community to be a part of. That's why I'm here.
Yeah.
Yep.
We brought you in.
Yep.
We snagged you.
Sure did. All right. I think that's everything we got for today.
Yep.
Yeah. So without further ado, we'll see you next week. Bye, everyone.
Bye,
Say bye to
everyone.
Dan.
See ya. See you later.